All right, all right. Welcome back. Welcome back, friend. Thanks, host 00312 for your follow. Much appreciated. This week, we are going to be working on part 2 of our little prototype project to try and make an event-driven web application. We are using nothing but PostgREST, which is an awesome project that gives you a REST API straight from a Postgres database. Very minimal configuration. And in order to implement our business logic or our control plane that's going to like interact with things that happen in our application, we're going to use the library we wrote called replicant. And so replicant's going to listen to changes to our database, and we're going to write a service that interprets those, that receives those changes and interprets them into like commands that do stuff in response to those changes. Right? And this is kind of like an idea of an event-driven kind of application where your application can be written on your database, on your Postgres database, doesn't have to know anything about event-driven and whatever's, right? It just reads, writes data as you would in a REST API, and then we can have services downstream that read off of those changes and can react to things and do all that kind of stuff. So yeah, we're sticking with the idea of doing like kind of like a cloud controller, although we're not probably going to implement a full thing, but just to show that we can do it, kind of like prototype it out, right? Cool. So that basically looks like this. Well, last week I think we left off. We're having some socket connection issues that we had to debug with replicant not being able to connect to the database, possibly due to the way we set things up in the database there. So we're gonna figure that out, and hopefully all the other like running out of disk space issues I've taken care of this week, so we won't run into anything else. Maybe, but we'll see. We'll see. So I already went ahead and started the Postgres server, so I'm gonna start the PostgREST server, PostgREST. And that's going to, actually, let's go to the netfil directory for that. So we put the configuration for that in config. Now PostgREST we have here, logs in as authenticator, has the anon role as webanon, and then changes into other roles as you log in, which we figured out this was the JIT secret's all about. And all that, yeah. So that should be good. Download PostgREST. It takes our config file. Ba-bow. And netfil. It's going to pull up kind of like the Scratch SQL file we've been using. And so I went ahead and I created another table, subnets, just to show what relations look like in PostgREST as well. So when you have things that relate to other things, as you commonly do using foreign key references in Postgres, that kind of gets set up like this. And if we connect to the database here, netfil. All right, that'll work fine there. I'm going to turn on the ninja snitch here on my end. Yeah. So let's just look at maybe api.routers. We got some data in there. Oh, we forgot from. A couple of routers. And subnets. couple of subnets relating to routers. Wow. Subnet route, really subnet mask, whatever. The networking stuff is slowly coming back to me. Yeah, this is just a fake pretend setup anyway. So, anyways, that's the idea. They're related by foreign keys, and now what we get with our handy dandy PostgREST interface to this are like just these nice little REST requests. We can post and create a new one. We can get our routers. Let's delete that collection here. Make a get request to routers. All right, we got 3 routers now. Okay. And we just see the routers here, but we want the the subnets with each router too. Right? How do you do that? Well, fortunately you don't have to go and go to subnets and pull that down in a separate request and match it up to your routers. You can just do that through query parameters. More key constraints. So you can select different fields with just the select keyword. And then if you want the relation, right, we can get subnets with the parentheses of the different fields we want and the subnets. All right. So we can select subnets. ID subnet route, I think I called it. And of course, we need all of the. It's just the subnets for the router. Right, router name and subnets, say. So it knows even the column name doesn't exist because I'm a silly person. We called it nickname, not just name. So if I type that in there, that should do it. All right, so that's how you select that stuff out. And then, yeah, if you want to post and create a new subnet, then you post to the subnet's endpoint. You want to post and create a new router, you create it here. And then on the back end, when those events come into those changes, which we'll see when we get that working, we'll be able to see new router created and turn that into a router created event. And then we can, in response to that, go actually provision a router in our cloud, whatever cloud backend we're going to provision that on. Yeah. So that's that. Let's get the other part of this working. Now, I was looking at a bit of the code, so I wanted to kind of figure this out, why this isn't working. When we run this program, we couldn't get the socket file descriptor. And that comes from here. And PG connection string of the settings is not working for us. Yeah, because as soon as we go to get the socket from the connection, the socket comes from need to do POSIX types, I think. And it just gets the socket out of this connection object here. So if this isn't actually connecting, then we have a bit of a thing. So let's just go to nfil and look at source. I think we hard-coded this all in here. No LSP, no thank you. Right. So I'm trying to use the jkin user with no password. Oh yeah, we're trying the Hackday database as well on localhost. Ah, cool. Cool. Oh, right. And I wrote a bunch of test code in here, so that's not combined because of all the holes. um, so let's just... well, just replace that with undefined. Okay, that's better. So that's working and connecting to the Hackday database. We need to connect to the NFFail database. Cool. So we've got a replicant exception here that the replication slot was not created in this database. So that's because when I ran the program last, of course, it created the slot in the Hackday database. So let's just quickly fix that. PG replication slots. Yeah. There's NetFail service. I think it's slash PG or application slot with the slot name. Oh, it's not that. Just delete. Or is it drop? Maybe it's PG drop. There we go. There we go. Cool. So then when we run this, that should just connect to that replication slot. It should be created now and active. It's active T. We got a PID serving the events for that slot there. Cool. Awesome. So now, if, so the way we got the program set up, this will just print out the change, return the next LSN as we need to do with that callback. So now if I actually write, if I do that post here from this collection again to create a new router, as a post, localhost routers, the nickname, we'll call it router woohoo. And we send this request, we should get the change pop up down here, which we do. All right, so that's how we're going to react to things happening in our database as they happen. Right, and we can implement our business rules on top of that as those things happen over time. We can react to those things and just say like this happened, then this happened, then this happened. We can log those things out into a stream, you know, and then we can have all kinds of services just listening to that stream for whatever they need to do. In our case, we're going to write a little service tonight that's going to turn this change and map it to an event in our, like a command in our domain, right? And we're going to be, the domain is going to be the cloud controller for the router service. And we're gonna do that. Cool. All right. So quick review on domain-driven stuff. Now, normally I would be like documenting this stuff in a schema spec or doing like a whiteboard session, something like that. Right, but a domain, think of it as like one sort of like important concept or object or thing that your organization and business cares about, right? If we're building a cloud controller, that's going to be our router, provisioner, whatever. You know, like our vRouter controller or something, whatever we're going to call it, doesn't really matter too much. As long as the words you use line up with how the rest of your organization would refer to this concept, this domain, right? That's the general idea, is we all want to be using the same terminology throughout. But within here, we have the command that it can accept, right? One of those commands is provision a router. Or just provision, because we're always going to be talking about a router, but provision router. All right, so within here, we can give this the command provision this router, and then router's controller is going to go off and do those things. And one of the things it might do is it might respond and say, okay, router's created, router provisioned. I did it. Provisioned. Okay. Commands given in the present imperative tense, because we give it as it's like we're telling the vRouter controller, do this thing. One of the responses to that could be, okay, the router has been provisioned. It's written in the past tense because it happened already. It's done. I did it. The other thing might just be no, or invalid command, or parameters are wrong. I can't do that. Cloud service is unavailable. I can't. And if we care about actually logging those things in the context of this domain, in this router controller, and this user's router, we might want to record that event. Whatever. In our case, our app today, we're going to be mapping the changes into this command. Right, we're going to map it to the command, and we're going to tell that's going to tell the router controller, okay, the router controller service is going to see, okay, I saw a router provision command. I'm going to go do that now. We could have like a log and output these events to an event log of what the router controller did. And so we might write another table for that as part of this, maybe. But basically, like, we could write this to an event log where we say, okay, the router is provisioned. It's done. Here's the cloud ID I got from, here's the ID I got from the cloud service and a whole bunch of other data related to that router. We could even react to that event and like update the state of our router in our apps table, as we saw in our schema. Right over here. Let me pull that back up. Routers. All right, we have a provisioning state here. So we might give the command, like initially when you create it, we'll just fill in this field here with whatever the state is. Right, it's nullable. And actually, this might not be the best way of doing this, actually, with this. But the idea is that we could update the state from the events, right? As the event comes in, we can say, okay, it's provisioned now, so we could change the state to provisioned. Cool. There's so many things I want to talk about with PostgREST and stuff like that too. Because a lot of people have a lot of questions about that one sometimes. Like, how would you build a whole API without writing any backend code? Like, why would you do this? Well, turns out you can get pretty far with this It's really good for prototyping, but I think you can do a lot more with it than just prototypes. So anytime you need kind of like a backend service, but you don't want to have to, you don't really need to write all this extra code to like just serve a bunch of database tables to the front end in a REST API. Just go with PostgreSQL. Like, it's so cool. It's so nice to be able to do that. There's other projects like Haskell, if you need GraphQL, does the same sort of thing, right? It reads the schema here and you say, well, James, oh, I'm going to get into it anyway. I'm sniping myself on this. All right, slight diversion. So another thing you can do is that because this reads right out of the tables right out of the database here and serves it straight into the API. Right, if we make that GET request again to routers, you know, we got this provisioning status. If it's null, we just get null here. We can fix that so that there's like a default value for it. And that's so the user can't set it when they post to it and stuff. There's ways we can do that, but we could do it all in Postgres. Right, there might be other fields too where it's more processing logic metadata, like control plane stuff. Maybe even like the provisioning state, for example, or whatever. Maybe you want to implement soft delete, things like that on certain things. And you don't want those fields showing up, say, in the API. How do you do that? Well, one way you can do it is that in your API schema inside inside your database, right? This is an API.routers. You have your public views of the data, but those can be database views, right? Postgres has a way called views that are kind of like queries. All right, so you have your actual like physical tables, store all the data, metadata, and everything aside. But then you create views that just query for the publicly facing view of that data. Right? And you can manage it that way. And that has a lot of really cool benefits too. Like you can, views are like security definers in Postgres. So because they use a query to query the underlying physical table in order to create like almost like a virtual looking table, you can intercept the queries on the view and implement specific logic like fields that you're not allowed to write to. You can intercept certain fields and say like you can't write this field and just make it immutable. Along with other things like saying only certain people with certain roles are allowed to change certain values and things like that. You can do all kinds of stuff that you need to be able to do with that. So fear not the PostgreSQL. Fear not the SQL. It'll save you a lot of time. But anyways, we're doing it here on the stream today just to save us time because we just want to prototype this thing out and really want to get to the meat of the backend. So let's get to that now that we have this going here. Ooh. I'm doing a lot of talking today. But what else is new? Okay, so we need to map from a change to our specific domain events. We're going to map those out right now as, say, provision router and rename router. All right, so provisioning a router, there might be a bunch of parameters to it in a real application. We're going to give it like a string, which is going to be like our ID, but we should really have like an actual ID type and all that kind of stuff in a real application. Okay. And then we got to map the rename, and we're going to do a rename router as well. We're going to have a rename router command. So our users are going to provision a router or they're going to rename a router, or this service will have those two commands available, at least in the domain. And I don't know, we'll figure out events in a bit. We're going to do this part first. So we're going from change here. This is the function here. What I think is neat about this is that when we look at changes down here, they contain a list of deltas, because each single change object represents one transaction, and that transaction can have multiple statements, like queries and commands and things, queries and statements, right? In our case, we're getting statements, so like inserts, updates, and deletes. You can have one or more of them. Some special ones might even have none. I think that's a message kind. So what I think is neat, a little bit neat about Haskell, and some of you are a little bit more experienced might already see this, but we have to have some kind of either type here. I don't think we actually need a list of router command. I'm going to go with router command. I'm going to change this up a little bit. But we can't get away from having either or maybe. And the reason for that is because of this list. If you look at a function, and now Haskell functions are not like pure mathematical functions, but in that world of pure mathematics, functions, you might hear like functions have like a domain and a range, right? The domain is like the set of values that go into the function, right? There, in our case, that's change, for example, right? And then the range is the stuff that the domain maps to. So like that's the output value you get from the function, or what it maps the domain to. Now for a function like plus, for example, on natural numbers and integers, that maps to like +3, for example, maps everything in the entire domain. Every natural number you can add 3 to. Every integer you can add 3 to. So that function is like total, right? Maps all of the domain elements to all the elements in the range. From change here can't, right? We can't map all the possible different ways that you can write a transaction in SQL to our commands, because we've only got 2 commands that we're interested in. All right, so we have like a partial function, or I think that's the way you can think about it. If somebody knows the better terminology, then please speak up in chat, enlighten us all. I hope I'm doing an okay job. So in those sorts of cases, you have to have a way to show that you're missing some part of the domain. You can't map the whole thing, and that's going to be, everything else is going to go to our error types, and otherwise we're going to get a valid router command. So some of the things we can map, some of the things we can't, and those are the things we know about in this case. We have like a pure return type here, either something or something else. So I was thinking about this a little bit last week, and we don't really need to map the change, the list of things to our router command. I think what we can pattern, because we can't pattern match on all the different lists, possible lists of possible transactions that can happen. But we're only interested, at least for a prototype, and when you're building a real application, in particular shapes of that list with particular values in it, particular deltas from particular tables, in fact. And so we only need to pattern match on very specific changes. And the rest can go to our error type, or the left side, and the rest can go to and those particular ones can go to the right and become router commands. And we only need to map to one router command. So that's basically what I'm going to do here. I'm going to get rid of this traverse nonsense stuff, which was kind of just like off the top of our head kind of stuff. And we're going to do this way. We're going to pattern match on change deltas. Right, so there's very particular ones. We want this W insert one. And we'll just take W insert like that. I think that should work, maybe. We're going to take update for rename router. We'll map that to something. And everything else, I mean, we'll figure that out. But basically, who cares? Who cares, right? Who cares? Okay. So, we could write this as like, what do we want to do for this hole? Well, this one on the insert. Actually, no, I want just the insert, INS. Yeah, we're not going to get any help from LSP tonight, it seems. So I'm going to stop this here and put this on our build so we can see that hole. I'll leave the other ones undefined for now so we can ignore them. Yeah, that's fine. I'll ignore that as well. That's not a valid countermatch there. Okay. Insert. All right. So INS insert. So the insert's going to have all of our data about the insert, and we only care about the one table in this case, which is routers. That's tables within the realm of our domain and what we're interested in here, in this from change function. So, since we don't have LSP here working for us to bring up the type, I'm just going to bring up the code for it. Database rep. Nope. Replicant. Yep. And message. Insert. Okay, that's the type there. So we can even make sure that it comes from the API schema, not just any other schema that we're interested in. So we could put this under a pattern guard. Where the insert schema is equal to API and insert schema, insert table of the insert is routers. All right, any other inserts, again, otherwise we don't care. It'll go to the left of our either. We'll leave that undefined as well for now until we get to it. Sorry, that shouldn't be equal sign because this is not a function. This is pattern. So it should be an arrow. That's proper. Okay. So we are in our hole. And this expression here, So our bindings, we still have insert, we have change deltas, all the other things. Cool. So we need to pull something else out in here as well, right? Column is also a list. When we're doing an insert, we could insert just one column or many. So we're going to have to make sure that we have all the fields we need to implement our command in this insert as well, in order for us to get an actual router command. So already that's kind of two kind of error, like 3-ish errors. So we're going to have an error case in here as well when we don't have the right number of columns. So how are we going to do this one? Well, in our case, it's pretty simple because our table is kind of small in our prototype, right? We only have the ID and the nickname provisioning stable. We're going to ignore that for now. We just want the ID and the nickname, maybe. In fact, in our thing, we only have the string and string. So let's just put those both in. So we could use do notation here in our either case. We're going to get the ID column out and the name column. Something like that, and router nickname. Some kind of action's going to go in there to get those out. And then we have to return our command, which is going to be version router with the router ID and the router nickname. Yeah. That can also be rewritten a better way, a slightly different way, which would be what is being handed to me right now, which is to use functors and maybe applicative instance as well, I think. And so in these holes, we just need to provide our functions that are going to go from, that are going to return either something. We're going to take them from the columns. It's the insert columns of the insert. All right, I already know we're going to need a note on the other side, a function called note over here. It might be like a missing parameter error or something, but our left side of our either right now is just a string. So we need a function in here that's going to take the list of columns and is going to return a maybe the one we're looking for. I don't think I have note locally. That is maybe some a B, oh, maybe an A, maybe B, and either A or B. I don't know what the parameters usually call, like, I don't know, we're writing this locally, so whatever. Right, and if we get adjust value, then we can map that to right V. We get nothing, and then we just return left. That's essentially note. Probably written that on the stream before. There is libraries that define it. I just don't want to be bothered with that right now. It's just faster to write it out sometimes. Cool. So with that in place, we have a function in data.list for this. I believe it's just find. Some element, some change, that's got to be bool. All right, so the columns, show that type as well. As a name, a type, and a value. So in the case of find, we care that it's the ID. More like this. And that should work. Oops, router. Provision router. Yeah. Oh, insert columns. Insert. Apply to too many arguments. Oh, yeah, I forgot the apply operator there. Let's talk about that at some point at work. So the way I read this, you've probably seen me do this a lot on stream. I use a function composition a lot with a dot. And I use this a lot because like I find point free style like my comfortable default, except where it doesn't make sense for readability reasons, because sometimes that happens, but it's pretty rare. And when I can't do point free, then I use the $sign to apply the composed function. And so I tend to verbalize this mentally as like note after find, after insert. And the $sign I verbalize as applied to. I don't know if anybody else does that, but that's how I look at it in my head. And I've tried teaching Haskell to people before, and I think this is some kind of a style that is a little bit confusing. But once you get used to it, it makes total sense. To me, at least. I don't know. You get used to it, and it's just like, okay, no problem. That's the way it should be. But it also really works well with this idea of using typed holes. And as we just did here, we started kind of like with just the first function. We knew we had to get the columns out of the structure, out of the record. And then what to do with that, right? You just put a hole and a dot, and you're good to go. So that's kind of why I like it. So let's do it. The next one is going to be fairly similar. So we might be missing the router nickname parameter. And we'll make this come back around here. Insert columns. Insert. I think that'll do for that. What is it saying here? Oh, okay. Yeah, so overloaded strings, because it's all text. Oh, blah, blah, blah. I don't know why we have all of these here. I mean, they don't hurt. Oh, yeah, okay. I think I know why. Type applications, though, I don't think we're using right now, but I just like that one. So we'll leave it there for now. Overloaded strings. And so here we have a type mismatch error. Is that my problem? Is it an operator precedence thing? No, doesn't seem to be. Okay, I'm going to go back to my do notation for a second. Maybe I got the hlint thing a little bit wrong. So this line here would be the router ID. Let's camel case that. This one here would be the router nickname. And then we return pure. Oh, let's see, yeah, parse errors, parse errors. Okay, that's fine. And the pure should be back there. Provision router should be back here. And router ID, router nickname. Could you... Right. Oh, right. We're missing a step here because we're expecting strings here, but we're find is returning a maybe column. Right, so we're missing a step here. Okay, cool. And what is that? Well, we need the value out of the column. Right, we're going to get a wall value, which we also need to pattern match on. We can also check on the column type and stuff as well, just to make sure that we're getting the right, not only the right name, but the right type, so that they match together. It's a little bit of a stronger guarantee that we're getting the right thing. If you want to be super careful. So we need to map the column here to a string. We could do that with a function. I think we could use record wildcards in a lambda. And what are we going to do with the wall value? That's a good question. We need to return a maybe. Oh, in fact, we have to fmap over that. This fine's going to return a maybe. So If we return a maybe here, we're going to get a maybe of a maybe of our value. Like if the column type, we're expecting to pull out a string here, but for some reason we're getting a wall value of a bool. That would be bad. Yeah. And we have to handle that case. Have to. So. We could join. It's kind of ugly, but it's prototype code. If we, maybe walls, maybe string, maybe walls, maybe string. Of the column value. Right, we might write that as like this. We can pattern match on the wall string S. Return S actually will be maybe. And then in any other case, that should be an equal sign. We return nothing. And can we concat map? I'm all right. Reverse fish. Rocket ship. Oh, it's not in scope either. Oops. Let me bring it in the scope. Database. Replicant. Message. That should bring it in the scope. Right, it's maybe text because it's all text. So we just have to hack that. T.hack this. I don't have that in our package. So let's add text. It's almost invariably going to be a dependency of pretty much every Haskell package, I think. Text. No, unpack. Sometimes I get them wrong, the wrong way around. There you go. Okay, that's the other whole, kind of the same thing. Just a different column. Reverse fish column. So this is getting to be pretty ugly, but we'll fix that up in a second. Maybe wall string of the column value. Okay. Yuck. So this is kind of one of the drawbacks of this style as well. Although I don't see it as a drawback. I just see it as like, if I'm getting a very long composition like this, we just need to refactor, and we can refactor just using simple substitution for the most part when you use this this kind of style. Okay. So what are we doing here? We're basically trying to get a column value out of the list of columns. So really, we could call it get column value. We're gonna call it naming things hard. Get column string. I don't know. Basically, we're gonna parameterize the column name we're searching for. Here, nickname. The other one's like ID. So that's gonna be a string. The list of columns. And then we're gonna return either string or string. And essentially, we're going to take column names and we're going to substitute. We're just going to take this whole thing. Up to here. And then I'll just pull this down here. Pull that down there. So ID I'm going to replace with column name. And this note error. We can just I think we even need the show there. Ooh, let's call it, we're shadowing the name, so we'll just call it CName for short, the input one. So it's expecting text. So then we're going to need one back there. That should work, maybe. All right, so we have the text and scope because I didn't do this right. There we go. Data text. There we go. Cool. So now we have get column string. We can substitute that up to here. All right, we're going to get the ID column on this line. Now we're going to apply that to the insert columns of insert. And this one was nickname. And apply that again to this one as well. In fact, I think we can actually do it our composy-wozy way. Comme ça. Yeah, just to be a little more consistent in style. There we go. All right, so we brought that line down a little bit. That's looking a little bit more reasonable. A little more readable now. Yeah? Okay, I like it. Let's uncomment some of these undefineds now. So in the case where we can't match out the insert and the change that we're looking for, it's based on the schema and table and the column. We just need some kind of error. Now, this might not necessarily be an error. Depending on how we react to this either, we could, do different things like just pass on this change to another domain or, maybe another domain downstream from us. Might want to do something about it. Maybe we just want to log. Maybe we don't really care. We just got to put something here for now. So unexpected insert. Really shouldn't. Something to do with that. Same with this one down here. Anything else we don't understand. We just don't handle that change. We don't know what to do with that. We don't know what to map it to in our business logic here for this service, this domain logic, the logic of this domain here. So in updates, we're going to do basically a very, very, very similar thing to inserts. We could do a pattern guard. And we could do table match as well. In this case, in the update case, right, we're going to get probably the ID of the router that was being updated, the row, and we want the nickname column when we're doing this. It's not a mistake to update any other part of the router necessarily. So it's not really an error. We're just not mapping that to anything in the domain. Like this service doesn't understand anything. So we'll do kind of a similar pattern here. Router ID. In fact, I think we could probably just copy that whole thing. We'll just change it from provision router to rename router. And it'll be string and the router ID and the nickname. And what's the problem here? Oh, right, we're pattern matching on inserts still here. Should be update. So insert here and here is update. And insert column as well. Sorry, it's updated here and there. Yeah. And of course we renamed ints to update of D. Yeah. Just like that. Bazoom, bazoom. Okay, cool. We compile again. So there's our domain mapping from changes, right? So we get the input, the changes as input. We're mapping them to our router commands now. We have a way of doing that. So let's try that out. Let the command equal from change of the change and print the command. Oh, from change of from change. Oops. Oopsie daisy. No, just change lowercase. Thank you. Okay, so then we can rerun this. And now, when we create a new router, we'll go to post here. We'll create the fooest router, that ever food. And now we should get, instead in this here, we should get a domain event, the command. And there it is. All right, so now whenever somebody posts to that endpoint, we've reacted to it, we've created a provision router. And as we build out our service, we're going to have a way of interpreting that provision router command into some action that's going to call out to our cloud API and do a bunch of stuff. Update state, update other tables in our database to acknowledge that the work was done and is finished and all yada, yada, yada. All right. So the state of our router and the difference between a event-sourced and event-driven applications, very similar, is that our event-sourced application, we would be deriving the current state of a router from a list of events, like I showed you in like kind of the very, very beginning when we started this little prototyping project. And an event-driven kind of architecture is more like having services that react to events as they happen. They are driven by the stream of events. So we might still record all of the domain events that happen in our router service for other things to also react to as well downstream from that. Right? Because you can have other domains talk to other domains and send commands to those, interact with each other. And mapping things out into like that domain logic, that domain-driven design logic kind of helps you keep track of how all those things interact and in what ways. And also gives you a good point for like migrating to different architectures or when your business logic changes over time, giving you a good adaptability to those changes without having to like re-architect your application or change too much, where change isn't necessary, I should say. It's not always the right architecture choice, but it can be very useful in a lot of situations. So I think for this kind of setup, it's kind of nice. So the other thing is we might rename a router. We could do that with a patch. I think PostGRS supports patch. All right, let's see. It has put. All right, this is super cool, even on conflict. Super nice. Does it have patch? Yeah. All right, so patching, we just do that, where the age equals whatever, and then the body is the part of the resource we want to change. All right, where ID is equal to, say this, the fooest router. And we want to change the nickname to just, it's not really the fooest, it's really just the foo router. Made kind of a mistake there. So let's try that. We got a bad request. I couldn't figure out the filter for that. So that's just a PostGREST thing. How do we specify? Is it eq dot something? Is dot. Okay. It might be like, yeah, like eq dot. Okay. So you got to specify an op, like this kind of operator type thing. Eq dot. Let's try that. There we go. All right. And we picked up that change that we renamed the router to foo router. So now we have these two commands that have happened. Provision router, rename router. Presumably once the thing is provisioned, we'll have an event history for our router, right? Initially it was created with as the fooist router. We didn't, even though our application mutated the row in the table and now it's foo router, we didn't throw away that data that it was fooist originally and was renamed to foo router. We'll have an event for router renamed. That says at this time it changed to foo router. Cool. So that's the gist of that. Isn't that cool? Right? That's one way we can use replicant and sort of map database changes to domain events within a service and have these sort of rich domain events that map from our queries. Now, you might think one trade-off to this here as we're mapping these queries that come in. I was saying at the beginning when we were doing this mapping stuff that, you know, the domain of changes is really, 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 really large. And the range of router commands that we have is very, very small. It's very finite. It's only 2. Right? So that's why we have either there. We can't avoid having some kind of type to express that partiality, if that's the right term. Where we can't map all of the elements of all the possible queries that can be in change to router commands. So we're kind of matching them based here on like what schema and table it was in, that kind of thing. We're pulling out the ID and nickname, and if we can't pull out those columns we're expecting, then we'll return an error. Otherwise, we get the provision router command. So you might think like, well, what if somebody wrote a query that inserts into this table, but only inserts one of the values that we need here? This is only going to map when these specific columns are here. I don't think we need to map over any arbitrary query, especially, well, in this particular case, if you're using PostGREST, because it's, well, maybe it's not such a drawback, but yeah, maybe actually it's fine. Now that I'm thinking about it a little more, because if we had to like service any possible insert query, you know, you could rename. You can set those values that you're going to set to just the thing. So yeah, no, I think this is fine actually. The thing I was going to get at anyway was that, you know, there's lots of different insert queries even, because we're pulling out of those columns, right? There's another list in there. So another sense of partiality, but I think in this case, actually, this is pretty good. Now, actually, now another possible drawback to this would be that if there were other things inserting to this table. No, I think this is pretty good. Yeah, and you'd be able to deal with that anyway. You know, if there was, for some reason, your application made really large changes that involved several queries, you know, we'd have to do more work to match out on the lists on this side here of the pattern guard. But it should be possible to eventually get down to your domain events from those changes. You can map those queries over. So in a larger system, I can imagine this being a bit of a point of contention where you're going to require a bit of coordination with your team. If, you know, instead of using PostgreSQL, you're writing more of an application that could be doing multiple queries inside of a transaction that you need to match on. You might need to keep this mapping in mind when you're discussing those changes with your teams. If you don't own the whole thing end to end, but yeah, I think this is a pretty cool little pattern. So now we can do all our business logic in here, react to changes to the table in real time. And then, yeah, so almost 9:30. Why don't we get started on that part this week and then see if we can wrap up the event side of it next week. Just to kind of cap off and bring this sort of full circle. So now that we have the command part, we need a way to actually go out and call out to our cloud service to provision these virtual routers. So one way we can kind of do this is we can interpret the commands, right? We have like an interpreter for commands. You know, what would that look like? Now, that'd actually be fairly simple in this case because we have a very small domain. We can just do handle command or interpret command or eval command. Right. Router command. Now, initially, we might just want to do it like this. And that's pretty sensible. Right? Especially for a very small domain with a very small application. Why not just do it straight in I/O, right? So let's try that out. Let's see what, I mean, you can imagine what the code would look like, but let's just type it out. The provision router, which is not a record, so we'll just do that. Router ID and router nickname. And eval command. We have rename router. Cool. Cool. So really, if we have it in here, you can imagine we just have put strlen, provisioning router on the cloud. It's just a string, so I like. Instead of, it's I/O, so instead of put strlen, it could be an HTTP call, it could be writing to a file system, it could be writing to a completely different database. It's I/O, it's godlike powers. Router, blah, 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 router ID to router nickname. All right. So when we get the change down here in our main thing, pretty straightforward. We get the command from the change. Then we can eval the command. All right, then we're pretty much done. We want to rename the foo router back to fooist again. All right, run the patch. Oh, we haven't rebuilt yet, but you could basically get the idea, right? So don't file watch, just fast. Two. Why isn't it working? Sorry. Oh, right, because that's an either string. Okay, so if we don't care about the left-hand side right now, oh, we can just pattern match on it. Why not? Left. We just poster len. Not a change we're interested in. But if it is, let's just get rid of that binding then and put from there. But if it is, then let's eval the command right off the hop. And then we will viewer. And then we do need that, I don't think. Yeah, that should be fine. Always needs to return that. Yes, that's true. So we will make this a do. I'll put the pure back here after the case. Yeah, that's better. And I probably just got something mucked up here. Oh yeah, the putster lens just need to be applied to a string. What did I do here? Oh, yep, sorry. They should be in parentheses. Because we're pattern matching out the whole constructor, not a record wildcard. I was translating that from record wildcards. That was the wrong thing. So Scooby-Doo. Yeah, okay. Now, let's run this. Let's send that patch request. You should see that come in. And see that it renamed the router to the fooist router. And if we rename it back again to foo router, we see it's foo router again. No, I meant fooist. Okay, cool. So, if we didn't have the technical issues we had last week, probably could have gotten this done couple hours, few hours, and had a prototype of this going, right off the bat. I think that's really, really, really cool. But like this eval command is pretty okay. It's not bad, but it's not very testable. Because once things are in IO, how do you test that you've done all the things eval, like how do you test eval command that's actually done the things it's supposed to do properly, right? And so that's kind of where we need to come up with a strategy for that. One thing that we can do is we can parameterize out the monad, the IO. Right, so from our interpreter, it's not necessarily IO, but if we are in an IO context, when we run the eval command, then we can make that M an IO and do IO actions, or we can put it in a different monadic context. So eval command IO, for example. Maybe we could do it like this. I might be mucking this up because it's on the stream and that's just how I do things. And my brain kind of goes... Right, so here, we don't know anymore that like we're in a monad, like an IO context where we can run puts_len, right? We just know we're in some monadic context, which isn't enough information to figure that out. So this isn't no longer what we mean anymore. Right, this is actually eval command in IO. Right, this is what we had before. So I should just rename it to IO and leave it there. But that's only one interpretation of the command. We could have this be like a state. Right, where we have some mock state, mock service state. All right, so instead of IO, maybe we wanted in a mock service state where like mock service, so instead of eval IO, it's like email command and test. And our mock service state might be some state type thing that would have a way of us recording which calls were made to our to our services. Router posts. I don't know. I'm just making stuff up here. Just as an example of like maybe something we can do. Right, so oops. The idea is that we would just have something that we can record to. So if that's some kind of mock monad or like just a simple state thing where we implement all of the stringified versions of the HTTP calls that we make, that we want to make against our service, we can record them. So this one we can do it. And so we need, the other thing we need is like a router provisioning service thing. Cloud vRouter service. And that can be implemented as the same kind of pattern as well. Right. We might even use vRouter provision. Say vrouter, add subnet. Right, and then we'd have a way of interpreting those commands. All right, it takes a vrouter command and does that. Does something with those. And the idea, the idea with these, though, is that we can now have, we should probably come up with some way of the return of these commands to possibly return one or more events. And so that when those events get done, we can log them out in our main area here. Or we can log them to our events. Like maybe we want to record the stream of events as they happen, as we start provisioning things, because maybe it's a multi-step process, depending which cloud provider we use. It's like maybe we got to like do a bunch of other actions in the vrouter command space. But then we would use the interpretation of those vrouter commands when we're evaluating our mock service, our own commands from our service. Right? And so instead of just doing things in I/O, when we get our commands, we can do them inside of our vrouter monad. We can write our own monad, our vrouter monad, and just implement our vrouter monad and all of its handling in terms of that. And then we log all those events into our event store, and whatever we can do from there, we can do from there, right? You can record all the things that ever happened to a router over time. We can even go back into our database and, update the status of our physical tables, which then will draw, and then our API views will draw from those physical tables. So they'll draw the new state for our users. So our users will see that the router has now been provisioned when they go and query the API and look for their router, their virtual router. So I'm going to cut the stream off there for tonight, folks. Next week, we will cap off this prototype service and just kind of implement those little bits just to give you an idea of where you could take this. Maybe I'll throw the prototype code up somewhere. So if you want to actually implement this and take it further, just fork it and go from there. So this is one way to implement a event-driven kind of architecture with an existing application that's just built on a plain Postgres database that isn't event-driven yet or built that way. You can use Replicant to stream those changes to your services, and you can map those database changes to commands and events that your downstream services can then react to and be driven by. And so they can implement your business. You can implement your business logic this way. Maybe even use something like PostgREST as your data plane and just use that as your REST API to quickly stand up a service very, very fast and efficiently even, maybe. So that's all I got for this week. I'll see you next week. I stream on Tuesdays, usually 8-10 p.m. That's the Discord link. We have a channel for this stream here on that Discord and others as well. So if you like Haskell and you want to, or other functional programming languages, it's called Declarative Streams. Tap that link, get invited, get an invite, be on our Discord. It's fun. And you can always follow me, Agent Ultra, on Twitter and elsewhere, GitHub, and things like that. thanks again for tuning in and watching. May your monads always be free, and may your types always